Hello friends, welcome back to my channel Syntax Adda. My name is Ravi, and today I'm going to cover the topic solid principles. So this is in continuation with ongoing video series on design patterns. So first let's understand what is this solid principles. So this solid principles constitute of five design principles, SOLID. So these principles enable us to make object oriented software designs more understandable, flexible and maintainable. So this principle was introduced by Robert C. Martin back in 2000. Okay, so let's understand what is the meaning of each letter in this word solid. So we'll start with first word, that is S. So this means this is the single responsibility principle, and we can call it SRP, right? So according to this principle, one class should have one responsibility or job, right? If we are writing any class, we have to, we should take care like that class or that specific class should have only one job or responsibility. It should not be unnecessarily added with some other responsibility. Okay, let's take an example, right? So this is example of solid single responsibilities principle. So let's see the code without this principle. So we have employee class with different fields, name, salary, and hours worked, right? And this class is having constructor that is fine, which will be used to instantiate this class. Okay, and then apart from that, if you'll see, we have different getter and setter for these fields. Okay, but we are seeing this is the additional method here, right? Which is added to calculate the salary. And I think this should not be added here because this is the unnecessarily extra or additional task for this employee class. So this should be added to some other class which will take the responsibility of calculating the salary, right? So by doing this, it is increasing the modularity of your code, right? And like after refactoring this code, we can see uh, we can we can write this class with this name, salary and hours worked, and then this constructor along with the getter and setter only. And then we can have the salary calculator, which will take the responsibility of calculating the salary of the employee. Okay, so this principle is called single responsibility principle. Okay, so let's talk about the second principle in this solid principles. So the second one is the O. So O represents open closed principle, or we can call it OCP. So what does it mean? So according to this principle, any software entities such as function, class, or module should be open for extension but closed for modification, right? So let's see, this is an example, it will be more clear. So let's close all this first, and then let's see open close principle. So if you see here, we have shape interface, right? And it has one abstract method, that is area, right? So the other class which are implementing this shape interface has to implement this area. So if you see the circle, right? So it is having its own field and it is having its constructor, and it is implementing override means what? It is implementing. This is the this method is from the parent class, right? So this is from the interface. So since this circle class is implementing this shape interface, so this circle class has to implement this method. So it has its own formula. So if we'll go to the rectangle, the same way we'll have a width and height which belongs to this rectangle, and then we'll have the constructor in this, and then we'll have the area which is implemented with its own formula. Okay, and then we'll have one another class which will calculate the total area of the shapes like circle, rectangle, or which all shapes we will be passing from this main method, right? So we have the arrays of this these shapes, and then we are creating the object of this shape area calculator, and then we are calling the instance method called calculate total area, and we are passing the shapes array, right? And this will return you the total area, right? So since this interface, right, it if you see, this interface is open for extension, right? So any class if you want to add, right, later, let's say if you want to add the triangle, right? So we are able to add this. We are adding with this class. Triangle class is implementing the shape interface. It is having its own property, base and height, and it has its own constructor, and it has its own formula, like to calculate the area. So it is again implementing this area. So we are seeing, so we are able to add as many as classes possible without, without modifying this interface, right? Shape interface. So this principle, under which we are taking care of this design principle. This is called your open closed principle. Okay. So let's talk about the other one. So next comes L in solid, right? So this is Liskov substitution principle, or we can call it LSP. What does it mean? So according to this principle, object of a superclass should not be replaceable with objects of its subclass or subclasses, right? So without affecting the correctness of the program. So, let's say if we have any superclass and we have the subclasses, so subclasses should be able to substitute for the superclass. So let's see, that's in the action, right? We'll see the example. Let's close all this first. Okay, and let's see, this is the, we have the interface called vehicle, right? And it has the following abstract method. So vehicle can start, stop, accelerate, and brake, right? So these are the abstract method. Now we have the car, which is implementing this vehicle. So it is going to implement all this, you know a method, abstract method, which is present in this interface vehicle, right? Then we have, you know um, if you see there, we have the electric car. So electric car here is extending your parent class called car, right? So, apart from, so it means what? This electric car will extend all the property of this car, right? And it can have its own additional property or methods, right? So, like electric car can be charged, right? So this is charge battery, right? So this is like electric car we are extending from the car, right? Then similarly we have the race car, right? And we know the race car use nitro, right? So this is its own method, right? Apart from start, stop, brake, accelerate, this race car can use nitro as well. Okay. Now if you see the we have the one driver class, which is just accepting this interface, right? And it's calling start, stop, right, accelerate, and brake. And now if you see the main method here, right? So we have the driver object, right? And we have the car object, and we are just passing that car object to this method drive. And similarly, we can also substitute this electric car as well in this drive, right? So it means the vehicle is your main interface, right? So we are able to substitute this electric car, which is extending car, right? Car class. So we are able to substitute this one here. So same way we are able to substitute this race car also in the that main interface, that is your vehicle, right? So that's what the definition was. So according to Liskov substitution principle, right, object of a superclass. So object of superclass, right? So object of the superclass should be replaceable. So if you see here, so electric car is the child class, right? But we are passing the child class here, right? Race car is the child class of a car, but we are still able to pass it instead of the parent class here. So first example, if you see, we pass the parent class here, right? If that child class, if we have the child class, let's say electric car or race car, we are still able to substitute that subclass, or we can say child class, with the instead of your parent class. So this principle is called your Liskov substitution principle, or we can call it LSP. Okay. Now let's proceed further and talk about the next principle in this solid principles. So I stands for interface segregation principle, which we can also call it ISP. So according to this principle, clients or implementation class should not be forced to depend on interface they do not use. Okay, so it means when we are writing the any interface, and we have some implementing or implementation class or some clients which is going to implement that specific interface, then that implementation class should not be forced, right, to implement all its abstract method presenting your interface class. So here the interface should be designed for the specific task, and then the implementation class should implement this one. So let's say this is an example. Okay, so interface segregation principle. Let's close all this first. Okay, so let's say we have document. This is the document interface. Okay, so what we can think about, like we can open document, we can close document, and we can save document. Like in the broader sense, we can think about these three main operations which can be done by using document, right? But if we go to the specific document, let's say we have the PDF document. So this interface is extending another interface. So, and additionally it is having its own view and print. So apart from open, save, and close, we can view and print. So there are two additional abstract methods which we can include it here. So if you'll see the text document, what we can do apart from here in this document, we have three methods, right? Abstract method. So this interface means text document is going to extend another interface. So apart from save, close, and open, right, will this text document can also have edit and format, right? And now we can have the implementation class in place, right? PDF document, you can see, so it can implement PDF document. So what it will do, instead of apart from open, close, and save, it can also view and print, right? Similarly, if you see the text document implementation, like, so we have this public class text document implementation, this class which is implementing this text document, right? So apart from open, save, and close, we can edit and format. So here you will see we have designed the interface for the specific task, and we are not forcing the implementation class to forcefully implement any methods, right? So that's what the ISP, the main principle of interface segregation, is. So according to this principle, again I'm repeating, according to this principle, implementation class or clients should not be forced to depend on interface, right? They do not use. Okay, so it should be, so you should design the interface for the specific task, like, right, and then allow the implementation class to implement those abstract methods. Okay, so now let's talk about the last principle in this solid principles, right? So it's a D. So D means dependency inversion principle, which we also can call as DIP. So this is dependency inversion principle. So according to this principle, high level module, right? High level module should not depend on low level module, but yeah, both should depend on abstraction, right? So what does it mean? Let's see this. So let's close all this. So we have one logger service. Okay, so we have defined one interface which is logger service, right? And it will be logging the message, right? And we have different implementation class for this logger service. So we have the console logger service which will log its message. We have database logger service which will implement its service message. We have file logger service which will implement this, right? So which are implementing this logger service. So all these classes, right, are implementing logger service, right? Now we have the high level module, which is nothing but your logger. Okay, so if you see here in this class, we are injecting this dependencies, right? It seems to be we are injecting this dependency, and then this is the constructor for this class where we are initializing, right? And then it is having its own method where it is it is calling the log service dot log, right, and by passing this argument. So here if you see, right, so high level module is instead of dependent on this dependent on the low level module, it is dependent on its abstraction, right? So log is nothing but the abstract method of this logger service. right? In order to log this message, here we are dependent on the abstraction, right? So let's see, if we in the main method, so we have different um, object of the class. So file logger service class, right? We have the console logger service class, we have database, we have the object for these classes, right? And then if you see, we have this high level model, right? And we are passing this file logger service, then we are console logger object, we are passing this console logger service to this database logger, logger, we are passing database logger service, right? And then finally, we are calling log message, right? Which we had in this logger high level module class, that is logger, right? And we are logging this method, right? So we are also having the console logger dot log message, database logger dot log message. So here we are seeing this high level module is not dependent on your low level module, right? It is not dependent on any of these module. Instead, they are dependent on these abstract. No, if you see, this is dependent on your abstract method of lower module. So if you see here, again, I'm just repeating. So if you see here, logger service, this is the interface, right? And we have this log method, which is the abstract method here, right? And this high level module, instead of dependent on this low level module, it is dependent. These are the low level models. So it is independent of any of these modules. It is not dependent on console logger or database logger. It's like it is not dependent on any of these logger service. Instead, they are this logger class is dependent on abstract method. So according to last principle, that is D, right? So high level module should not depend on low level modules, right? So by this, this principle this principle is generally focused on decoupling of the modules, right? So we are just saying logger class is independent of these class, right? So this is called decoupling, right? So that's all about this solid principles. Hope you like my video. If you like, please share it and subscribe my channel for any further notification. Thank you so much.